Hey everyone, I'd like to welcome you to the fifth installment of my weekend project, the motorized antenna mount. This weekend what I was working on is incorporating my Bluetooth module into my motorized antenna mount design. Not gonna lie to you, it was a little bit tough. I was looking up information on that module, and I'm going to tell you a lot of information I found on the internet was true, but however some of it was actually false. So what I'm going to do is, after we come back from rolling the introduction here, we're going to talk about what I did in order to make the module, that Bluetooth module, work with the rest of my Arduino project for that motorized antenna mount. So don't go away, come back after the introduction. Here's the Bluetooth module that I'm going to incorporate into the project based on what I ordered from Amazon, not endorsing Amazon, that just happens to be where I purchased it from. The name of the module is BLE 4.0 Bluetooth module for Arduino. Some may call it Serious Wireless Module HM-10. So for the remainder of this project, we will call it the HM-10. On this, there's a few things that we need to pay attention to. First of all, that the power that's needed in order to drive this module, minimum power should be about 3.6 volts, maximum power about 6 volts, and that will be going in on our VCC. The second thing we should be aware of is that in terms of the levels of voltage outputs and inputs from our RXD, which is the receive, and the TXD, which is our transmit, they will be in the 3.3 volt range. So in other words, the transmit that's coming in, or the receive that's coming into the module, will be or needs to be about 3.3 volts, while the transmit, what's going out, is going to be about 3.3 volts. So if you remember correctly, the Arduino that we're working with is a 5-volt board, and so we're going to have to make some conversions or some accommodations when it comes to these, more specifically when it comes to the receive. Now, the reason why we're concerned about the receive is because the board itself can only take in it's suggested that you put in 3.3 volts because that would work best with it. Whereas for the transmit, that's going out to the Arduino. And if you have 5 volts TTL logic, 5 volts TTL logic understands that at least, I think it's 3 volts in many cases, is good enough to be a logic 1. So we don't have to worry about that. Our biggest concern is what is this board actually receiving here, and it should be in this range. So on the next slide, you'll see what we do in order to take care of that. All right, so this is for the most part what we were working with from last week. The only thing we added different is the HM-10 board here and a couple of resistors here in order to create a voltage divider to make sure that we get approximately the correct voltage coming in on this receive input. Now, in order to make the voltage divider work out, we can use a 1K ohm and a 2K ohm resistor, and these are suggested by a few websites that I saw online. So we're going to go ahead and try to do that. Ground is going to come in on this pin right here, VCC on this, and the enable and state will remain as is. So let's go ahead and construct the new circuit, or add on the new circuit.
Okay, so I used the two resistors to make a voltage divider up here. One thing I do want to mention though is I did not use the recommended 2K that some of the other people that I've found videos for said that you should use. And the reason I did not use that is because I don't have a 2.0K resistor. And so what I did was I used a 1.8K resistor. Now I can get away with that because the point here is actually to divide the voltage down to a smaller number from 5, more specifically around the 3.3 volt range. And so if you use a 1.8K, that should be enough. So let's take a look here. I'm going to put the multimeter in view. I'm going to have to zoom out just a little bit here. All right, so I've connected down here the common to the ground of the circuit, and then up here I have my positive, or the we'll call it positive. For the multimeter here, we have that connected to, and it just came off. Let's try that again. We have that connected to the red wire here. And so when we go to the voltage divider up here, where we're actually pulling the voltage from, you'll see that that's 3.21 volts. And that's more than enough, within that range anyway, in order to get the 3.3-ish volts to my HM-10 board. And so that will allow us to bring that voltage down so it doesn't cause any long-term damage, I guess you can say, to the board. All right, so now that we've done that, let's go ahead and we will talk a little bit about the actual code that I've written. All right, so let's go ahead and take a look at the code. I'm going to skip past the comments at the top. And by the way, most of this hasn't changed since the last time. There are a few parts that have changed, and I'm going to talk about those. So in here, we're still using pin 3, 4, and 5, same as last time. Here, the step count is set to 0. And the channel numbers, again, are based on where, what channels I can get from my office location. And then, of course, the degrees associated with those channels, and then the step numbers I need to move in order to get to those channels, or rather, the step position of each one of those channels. Number of steps, we're going to start that as 0. Array, this part has changed to array length. What I noticed last time was what I was doing was I was using just simply size of array, and I was looking at size of array of, let's say, I think it was the my channel number. And what I realized is that was not returning the exact number of entries into the in the array, but rather it was delivering the number of bytes. So what I had to do, I had to use this equation in here in order to get the exact number of entries in each of these 3 arrays. And that's each array separately, because they're all supposed to match, supposed to have the same number of entries. And so if I did this with any one of the 3, so in this case I use my channel step num, which is this one here, I can get literally the number of entries into the array. And so that's what I did here. The channel index, I set it to start. So when the actual program starts up and we start the program, right? What happens is that we're going to start at channel 4, which is the first entry, or not the first entry, but the second entry, or index 1 in our array. So that's where we're going to start. So the first one is 0, then it's 1, so on and so forth. So we're going to start at channel 4 by default. That's what this is saying. All right, so now moving on, and this part has not changed. I'm going to stick with the 9600 for the baud rate. And then when we come down here, this part now has changed. I had to add in an if statement here. And so what the program is doing is it's sitting there waiting for an entry. Once an entry has been detected, which is what this if statement is doing, it actually comes in here and it reads that entry into incoming value. Now remember, I'm going to be putting, no, I should say, what I'm going to do is I'm going to put 1 in when I want to increment through the channel numbers, and I want to put 0 in when I decrement through the channel numbers. So on the app that I'm going to use on my tablet, I'm going to either need to enter 1 or 0, and based on that 1 or 0, it's going to decide what it's going to, the program is going to decide whether it's going to increment or decrement. Again, 1 would be increment, 0 would be decrement. This part down here, now if we get to the highest value in the array, or the last entry in the array, if we increase the index, we'll have a problem, because then we'll go outside of the bounds of the array. So we actually need to go back to 0. So this area here serves as like a wraparound. And so if we go below 0, we need to actually go to the highest number, or the highest entry into the array, or the last entry into the array to be more exact. And so that's what this portion is. It's just so we can wrap around the channels. So in other words, if you get to channel 69, it goes to channel 2. If you go to channel 2 and you're actually saying decrement, it goes to channel 69. All right, moving forward, let's see. The rest of this part here, this has not changed since last time, or at least I don't think so. And so at the end, we're going to end up printing off the information that was shown or completed. And so as you can see, I've already saved it and I've already ran it or uploaded it, but I'm going to do it again. So let's go ahead and do that. All right, so we're going to save it again. All right, so let's go ahead and upload it again. All right, and the upload is done. Okay, so here's an issue I ran into during the week, and working on incorporating the Bluetooth into the project. And so at this point, everything has been loaded onto the Arduino in terms of program anyway. And so I have the Arduino on, and I go over here and I go to Bluetooth, and as you can see, my Bluetooth is on. And so now it's looking for available devices. All right, so finally, the list of devices came up, and the BT05 is that Bluetooth model that I'm using, or module that I'm using. So I'm going to go ahead and click on this, and what you'll notice is that a message pops up, and it says that the pairing rejected by BT05. And so I click OK, and I tried it again, said the same thing, and trust me, over the weekend I tried it over and over, and so I continuously kept getting the same thing. What this is telling me then is that I cannot use normal methods, if you will, in order to connect to that HM-10. So I'm going to have to download a different type of app in order to allow me to connect to the module. What you're going to need to do is you're going to need to download a serial Bluetooth terminal. And again, this is if you're using the HM-10. If you're using the HM-10 along with the Arduino Uno, you're going to have to download a serial Bluetooth terminal. The one in particular that I chose was the serial Bluetooth terminal from the Google Play Store. And so I went ahead and installed it onto my tablet. Okay, so now we want to go to the BLE Serial Pro or Serial Port code that's actually, or app that's actually been uploaded onto my tablet over here. And the tablet, FYI, has Bluetooth, and there's no connections connected to the Arduino board from it. Okay, and go to devices. Once it's gone to devices, we're going to make sure that Bluetooth LE has been selected, and then we're going to tell it to scan. And so now it's going to scan through. I'm going to have to tell it to scan again because it hasn't detected the Arduino board and that breakout board with the for the Bluetooth. Okay, now I found it. It's at the very top. It says BT05, so we're going to go ahead and select that one. And so now you'll notice that it says that it's now been connected to it again. I'm going to zoom in just a little bit more. Ooh. It's now connected to it again. And so now that it's been connected to it, we can go ahead and test the program that was written. I'm going to input a 1. Remember that when I input a 1, what it does is it tells the Arduino board or the motor to start from whatever is position 0. And you'll notice that position 0 is approximately there. Okay, and we're going to tell it to go ahead and move to what would be now, if we put in a 1, it'd be going from channel 4 to channel 5, because remember channel 4 was where it began according to the code. And so now I'm going to go ahead and move the mouse over to that part of the screen because I'm a little bit far away. So you'll see the cursor there. I go ahead and click it. You'll see that the motor is now moving. After I clicked it, the screen over here says I inputted a 1, and it's now on channel 5 as I indicated. And so channel 5 should be, in terms of our degree, it should be 309 degrees from our opening position, which we consider to be 0. I'm going to go ahead and enter 1 again. And it's now going to go to channel 5. And channel 5, according to this, is at 83. Oops, I went to channel 8. Is at 83 degrees. I forgot we went to channel 5 before, so now it's channel 8 according to my list. All right, let's go ahead and input a 0. So 0 is what I'm going to input. I'm going to move the mouse. And it should take me back to the position for channel 5. And so it looks like everything is working smoothly so far. Okay, so reviewing what I was able to accomplish this week, I was able to accomplish connecting the HM-10 Bluetooth module, and that would be that right there, onto my Arduino board, and being able to control the stepper motor with from my tablet, which is actually shown in the back here. And so the way that it worked was that the tablet, I used the Bluetooth communications from the tablet to talk with the HM-10, which then talked to the Arduino, which then controlled the A4988, which then drove the stepper motor. All right, so at this point, we've actually gotten to the point where honestly, there's not a whole lot left to do to get the very bare basics of the program running. So it's going to be over the next about week or two. What I'm going to be looking at is actually now going ahead and putting together some sort of a final item that I can use. Of course, this is all prototyping stage, and we wanted to make sure that everything worked before we start making our final connections. And so we've gotten to the point where we've kind of, we've proven the concept here that it is possible to create that motorized antenna mount. Come back. We're going to finish up in the next about week or two.